All right. So all that explanations about the beginning understanding of trig function have been started out on the unit circle, which is that circle where it has those two special characteristic, radius 1 and center at the origin. But so now, what about when we're working with those general circles, meaning, well, I do intend to have those general circles to be center at 0, 0, but general means they are no longer radius 1. So radius other than 1. But then we still, let's say, take the center at 0, 0. The idea, the reason this concern being brought up is that in the end, if you're looking into just any x and y axis system, and now I don't even have to put up my picture anymore, just x and y coordinate system, then any point, any rectangular coordinates point with x and y coordinate value, any point there makes a distance from the origin, and that distance now is not necessarily equals 1. It's just some distance that we call r. So this distance here could be greater than 1, could be less than 1, or could be exactly equals 1. And so, but in the end, that radius there has a similarity with the unit circle in the sense that it's still going to create that angle theta at the center. And once again we refer to that as a central angle. And so there will be sine value and cosine value for that angle. The only connection, the only connection I need to point out here is that, so now when you're on and imagine that your circles here no longer have to be the unit circle, but once I nail down that radius right there, then there will be an imaginary circle center at the origin, but going through like that. But keep in mind now that this is a general circle. And so now, once you're working with a coordinates point, a rectangular coordinates point being on a general circle, other than not necessarily being the unit circle any longer, then we have a relationship here that cosine value of the central angle theta at the angle will be equals to the x coordinates of your terminal point. So we're still going to call this, which is basically a point, the terminal point. So we're still going to use so cosine theta is still going to be related to that x coordinates of the terminal point. However, here we're going to extend that to being a fraction x over the radius, that distance made from the center, from the origin of the x and y axis system to the point that we're currently at right here. And so that's indicating that this is the x, but we're dividing that by, this is the x. But keep in mind, x here is no longer being on a unit circle, and so the cosine theta value has to actually be x divided by the radius other than 1. And so, and then sine value of your angle theta is now going to be the y coordinates of your terminal point on the xy plane in general, divided by r, where once again r is that same distance made from the terminal point to the center or the origin of the x and y axis system. And so then, consequently, right after those definitions I have just pointed out, then so now we have a direct consequence out of that So first of all, back to cosine theta on any general circle, then equals to the x coordinates of the terminal point divided by the radius. Then we can algebraically rearrange this equation here by multiplying r to both sides, and what we ended up with is now we can go radius multiplied with cosine theta. This equals the actual x coordinates of your terminal point. So we now can, this formula ever since this point now become quite useful in a lot of computational work later on. So radius times cosine of the central angle, that equals the x coordinate of the terminal point. And so similarly, start out with knowing that, from just now, knowing that sine theta equals the y coordinates divided by radius r. And so we can rearrange by multiplying the r to both sides of your equation, and we consequently ended up with r multiplied to the left hand side times sine of theta, and equals the y value. And so what we recognize here indeed has become a quite useful as well, a formula to effectively find a y coordinates once you have sine theta given. So y coordinates equals sine theta, and multiply with the radius.